Hello, my name is Kishinyo. I am an eBay seller and I am an electrical engineer. I have been in my professional business for 25 years and I am going to make this video short because otherwise YouTube won't let me post it. Today I'm going to show you a new theory with the evidence in front of me here, a theory that you probably have never seen before, or perhaps you have seen something similar to it. You know, by theory, the conventional way to get more output is by changing the wire thickness on the transformer and the number of turn, and that is by changing the impedance. And this is the selector switch that select the impedance. Okay. Now there is a new circuit. There is a new method of improving output power without changing the wire or without changing the impedance, and that is a new rectifying circuit. Okay, with this method, you can turn a 3 kilowatt, okay, a 3 kilowatt into a 6 kilowatt generator easily. I will not discuss the theory of reducing the RPM because it's going to take much more time to explain it. Now let's go ahead and take a look at this demo here. This is a single-phase transformer. Okay, that is. Let's look at a chart here. Single-phase transformer is that guy. This is a three-phase generator or transformer. Okay, usually the three-phase require less RPM. Okay, the number 60 hertz per second, it really means a 60 turn per second. The generator is doing the revolution, is doing the number of turns, okay, 60 turn per second, as opposed to 20 turn per second on the three-phase generator. Okay, now let's take a look at this demo here. This is a single phase. The theory I use on this battery charger is the same theory I use on that three-phase generator. Okay, let's start off by looking at the basic concept of changing the output power. Here, people change the power by moving the switch, a selector switch, okay, to select a certain impedance. The first position. Let's go ahead and take a look at the impedance on that first position. Now let me hook up the test lead. Okay, excuse me, I'm gonna try to do it real quick because I want to make it short because. All right. So you see right there is 3.1 ohms. All right. Normally they check the impedance by the impedance meter. Okay. Since I don't have that inductance meter, I use the ohms meter, and that should be okay for now. Okay. So the first position we have 3 ohm. Okay, the second position we have 2.3, and the third position we have 2.1. All right, that is how they change the power output, by selecting the number of turn. All right, so let's stay with the middle one. All right, I'm not going to change that. I'm going to just keep it there, and I'm going to prove to you that the way to modify output, you can also just change the circuit instead of changing the impedance. All right, I'm going to keep it right there. Okay, it's 2.2 ohms actually. Sometimes it could go down to 2.1 depending on the temperature inside the transformer. You see there, 2.1. The colder it gets, the less resistance you're going to see. All right, when it gets hot, okay, the resistance kind of go up higher on the copper. Okay. But it's contrary on the semiconductor. All right. Now, so I'm going to show you the output power. Let's see what we got there. All right. On that second position. Now the label said it's 12 volt, 2 amp. Now I got much more than that because I got to switch to a 12 volt. Okay. So you see right there, 12 volt 48. All right. Now, you see that the label said it's 2 amp, but basically I got much more than that because I changed the wire on the secondary. I changed to a bigger wire. Okay, so now I'm going to put a load on it. All right, and watch that meter. Watch, it's going to go up to 15 amps. See there? Even above 15 amp. And why? Do you know why? And that's because I changed the secondary to a bigger wire. That explains why you can change the output power by changing the wire thickness. All right, now I'm going to turn on the amplifying circuit on the back here. All right, this is a jumper. All right, I turn it on using this jumper. Okay, all right, let me put that in, and you're gonna see the power amplifier right there. Look at the meter. All right, you see 38.2 from 1248. All right, so now I'm not going to apply this on my load because that's too much power. So I'm going to reduce it down. I'm going to use this light bulb instead. Okay, I'm going to use this light bulb and show it to you. See there? See how bright that is? Very bright. Now, I'm going to turn off the amplifying circuit. You're going to see the light will be dim. Alright, the light will dim. You'll see. Alright, so I turn the amplifying circuit off. Now watch it again. See, the light is dim. Not very bright. So that proves that the circuit itself is the one that doing the amplification. Alright, so that has nothing to do with the impedance changing or the wire thickness. So now I show you two methods of changing the power. Now with the same method, you can do or you can apply on that three-phase generator, and that's what I did. So whenever you see my item that sounds, you know, outstanding or something like that, or not outstanding, you know, extraordinary, sound like I'm trying to rip people off, but that's not the case. Okay, this is technically true, and this is the reality. So I hope that answers your question. All right, that's it for today. Thank you very much. Bye-bye.